HART Overview Part 1. In this session, we are going to discuss HART and smart instrumentation. HART protocol, frequency shift keying FSK, Pole/response mode, and burst or broadcast mode. Smart instrumentation. Smart or intelligent instrumentation protocols are designed for application where actual data is collected from instruments, sensors, and actuators by digital communication techniques. These components are linked directly to programmable logic controllers, PLCs, and computers. The HART, Highway Addressable Remote Transducer protocol, is a typical smart instrumentation field bus that can operate in a hybrid 4 to 20 milliampere digital fashion. HART is by no means the only protocol in this sphere. There are hundreds of smart implementations produced by various manufacturers, for example, Honeywell, that compete with HART. This group of lecture sessions deals specifically with HART. Request: it is hoped that this session is going to be useful to you. Please press like. Please subscribe. Smart instruments. At a basic level, most smart instruments provide core functions such as control of range, /0, /span adjustments, diagnostics to verify functionality, memory to store configuration and status information such as tag numbers, etc. Accessing these functions allows major gains in the speed and efficiency of the installation and maintenance process. For example, the time-consuming 4 to 20 milliampere loop check phase can be achieved in minutes, and the device can be readied for use in the process by zeroing and adjustment for any other controllable aspects such as the damping value. HART protocol. This protocol was originally developed by Rosemount and is regarded as an open standard available to all manufacturers. Its main advantage is that it enables an instrumentation engineer to keep the existing 4 to 20 milliampere instrumentation cabling and to use simultaneously the same wires to carry digital information superimposed on the analog signal. This enables most companies to capitalize on their existing investment in 4 to 20 milliampere instrumentation cabling and associated systems, and to add further capability of HART without incurring major costs. HART is a hybrid analog and digital protocol as opposed to most field bus systems which are purely digital. This diagram shows frequency allocation of HART protocol. This is figure 18A.1 and we shall be referring to this number in the coming slides. Here we can see that for 1 we are using 1200 Hz signal and for 0 we are using 2200 Hz signal. Frequency shift keying. The HART protocol uses the frequency shift keying FSK technique based on the Bell 202 communications standard. Two individual frequencies of 1200 and 2200 Hz representing digital digits 1 and 0 respectively are used. Figure 18A.1. The average value of the sine wave at the 1200 and 2200 Hz frequencies, which is superimposed on the 4 to 20 milliampere signal, is 0. Hence, the 4 to 20 milliampere analog information is not affected. HART protocol. The HART protocol can be used in 3 ways. First, in conjunction with the 4 to 20 milliampere current signal in point-to-point mode. Second, in conjunction with other field devices in multi-drop mode. Third, in point-to-point mode with only one field device broadcasting in burst mode. Traditional point-to-point loops use 0 for the smart device polling address. Setting the smart device polling address to a number greater than 0 creates a multi-drop loop. The smart device then sets its analog output to a constant 4 milliampere and communicates only digitally. The HART protocol has 2 formats for digital transmission of data: Pol/response mode, burst or broadcast mode. Pol/response mode. In the Pol/response mode, the master polls each of the smart devices on the highway and requests the relevant information. Burst mode. In burst mode, the field device continuously transmits processed data without the need for the host to send request messages. Although this mode is fairly fast, up to 3.7 times per second, it cannot be used in multi-drop networks. HART protocol. The protocol is implemented with the OSI model using layers 1, 2 and 7. The actual implementation is covered in this group of lecture sessions. Next lecture. Name of the next lecture is HART Overview Part 2. In the next and subsequent lectures, the actual implementation is covered. Request. It is hoped that this session was useful to you. Please press like. Please subscribe.